I'm excited to be doing this advanced workshop. Just to kind of get an idea of where everybody is. Who here is a developer or works with code agents or has ever worked with a code agent before? Okay, sweet, wonderful. How about people that do it kind of on the daily and are dealing with this in a normal environment? Okay, so about maybe 10%, quarter. Okay, sweet. So this is going to be an interesting workshop. My goal today really here is to introduce a bunch of patterns and what it kind of looks like to be coding with these AI tools on the edge in a complex environment that's far beyond a vibe-coded sort of thing. And how do we make these agents kind of work for us in these sorts of environments? So it has a GitLab repo here. I think everybody's heard me yapping about this already. But if you want to, this is available to come and poke at it while we're here to ask questions. It's also there for afterwards, if you want to go do it in your own home environment. That's perfectly fine too. Basically everything that I'm going to say here is laid out in more detail there with examples if you want to kind of go follow up on something afterwards. That's kind of the goal here. It's cookbook, a bunch of patterns that might be useful for the road. To go on to what we're talking about here today is set the problem state. I don't know how many people have had that day one experience with these AI tools where you prompt the thing, say, hey, I need this SQL query, and it just spits it out, and it's wonderful. And I think this thing, we're done. You know, I'm going to be out of a job in 2 years, and it's all over. But at least I don't have to do my work now. That's kind of what it felt like on day one. About 2 years in, you start realizing maybe that's not so much the case. There's a lot of problems with these things that really start to stack up in insidious ways. And it's really hard to see it happening if you don't know what to look for until you've got this big old giant puddle of slop sitting all over your code base. And so what we're going to talk about today is, number one, how to recognize the slop as it's occurring, and also how to counteract it, and some of the I guess, patterns and things that I've learned from working with this stuff over the past 3 or 4 years. All right, so a little bit about me. I've been in software development since 2014, about 11 years now. I've worked mostly with modeling simulation, data engineering, and now artificial intelligence for quite a while. I'm generally focused on vision transformers and multimodal agents. I've been working with those pretty heavily since about 2023, especially starting with, if you know what lava is. Who here actually knows what lava is, just to kind of gauge where I am? Okay, cool, awesome. So I won't talk much about vision transformers. But just very interested in that sort of area of stuff for seeing agents. We'll talk a little bit about that on the actual practical side today with the Playwright integration. I'm mostly focused on development environments and software factories. So how do you get something like this to work across a large group of people, focusing on software validation and verification, which we'll talk a lot about today. Has a big impact on how to make these things not put out crap. And then also peer review and analysis, which is another thing that we've got to do with these things quite a lot. In my free time, fun stuff that we won't talk about today is I like to do stuff with agents and diffusion for shared storytelling and tabletop gaming. So for all you Huntsville nerds that like to do some D&D or Shadowrun and all that sort of stuff, me too. Yeah, that's me. There's links if you want to find me, but whatever. Another little thing about me, I do a lot of talks at the Huntsville AI group. If you came to the earlier talk with Jay, this is his group. So we do a lot of sort of general purpose sort of stuff, but we also do this paper review series, in which I do a lot of those every month, where we go through some sort of paper that's come out and kind of go over some interesting topics. So a little bit of an idea of the sort of things that I'm interested in. A lot of things related to agents. So here's stuff that we've talked about the last year. Structured agentic software engineering, which we'll see a little bit of that today. Zero trust frameworks for AI agents. Memory. The reasoning review, because DeepSeek came out last year around this time, and so we had to do one of those. Some basic prompt engineering stuff and looking at Claude. Also very interested in multimodal diffusion stuff. So things like multimodal embeddings, the WAN diffusion models. We talked about rectified flow, and then also world models, so we can talk about iRobot and how its brains work. So if you're interested in this sort of thing, there is actually a group that talks about that stuff in town, so check us out. All right, I'm going to shut up about me and then talk about something else. What's up?
Wednesday nights, Hudson Alpha. Every other week is in person, and every other week is virtual.
Something like that. I would check the calendar to find stuff about it. I think that's the best way to check it out. All right, so there's going to be 5 major things that we're talking about today, and this is going to roll through the whole talk. We're actually going to be broken up into 2 segments. We're going to have a very sort of hands-on segment towards the end. I'm going to pick up my terminal, run through things. I have this app loaded up, and we're just going to kind of see what happens when these things start chaining together, if you have not seen that sort of thing. But I'm going to talk a little bit first about what are the sort of patterns we're going to be seeing while we're going through this stuff. And so the main 5 threads that are going to go through this is that we're going to talk about how to get our software environments to have this rigorous, opinionated validation that's necessary for keeping the agents on track. It's how to standardize your development environment so they're not seeing weird things that throw them off the course. How to get your tribal knowledge into an explicit form so that the agents can actually do the processes that are important for your factory. We're going to talk about this concept about specification-driven development. Everybody's been talking about this hot buzzword. It's just requirements. But we'll talk about it in the buzzword term. And then just the general concept of how do we optimize our code base hygiene. And so before we go in, just to give you context about what we're going to be looking at today, we have a super, super serious application here that is going to be our focus. Oh, I have to, oh, well, it popped up over there. 1 second, I'm dealing with PowerPoint stuff right now. Here we go. All right. There we go. Here's our super important application. We have the Raccoon Rocket Lab. This is our complex application. You know, it's got this front end right here, and we've got the ability to launch our little Raccoon Kerbal Space Program thing. I'm waiting for my Games Award any second now. Yeah, it does some stuff, but it's got a lot of things in here, even though it looks kind of stupid, that AI is really bad at. We have lots of visual things. We have animation. We have both a server and a backend running inside of a container with external services and databases. So all the things that make AI suck are going to be on full display in this application. So we'll be talking a little bit about what we're going to do to torment these poor raccoons and hopefully get them off the ground. All right, so hopping back to the presentation. All right. So we're going to go rapid fire through a lot of different concepts just to kind of define these things out to you. I'm going to give some short takes, but we're hopefully going to get through and get to having fun. So we're going to talk a little bit about these agent runtimes. Who here knows what an agent runtime is, has used one of these sort of things just to get a vibe? All right, a few people. We're going to talk about these right here. I think these capture a good microcosm of what things are available out there. There's like 9 billion of these things, but I think these are the ones that are the most significant. So we can talk about Claude Code, Open Code, Cursor, and Cline. So first up, talking about Claude Code, we're going to be using this one a lot today. Right now, it is, I think of Claude Code kind of like the beta test for what's coming for agent workflows. They generally seem to be implementing the workflows and patterns that other people are implementing down the road. So even if you're not using it in your day-to-day because of your potential security posture and where you are, it's a pretty good idea to get familiar with what's coming out of this because all of the open source stuff is going to have it in about 6 months because everyone's just copying its homework. So it's got a lot of super forward features, things like MCPs, skills, the rule file, all of that came from Claude Code, and they formalized it, and a lot of their stuff is doing open standards. I will say one thing, too, about everything that we're going to talk about today. I'm only going to talk about things that are open standards, and that are likely to be implemented in every single runtime if they are kind of trying to steal each other's customers. There's lots of things that you can do with just those things. So this is Claude Code. It's the only thing I will use this for is working with Claude Sonnet. For everything else, I actually use, not that one, Open Code. So this is a open source runtime that's pretty much on parity with Claude Code. Now it is somewhat newer, so you might not have it through your corporate review board, but if you are dealing with this stuff on the day-to-day, I would suggest checking it out because it's worth going after. It has very, very robust ability to customize it to fit whatever features and controls that you need. It's able to run with pretty much any model except for Claude Code now. It has direct integrations with Codex and OpenAI that's directly supported by OpenAI. So if you have a ChatGPT subscription, you can use this for $20 or whatever your subscription is a month with this specialized, highly feature-rich environment. So highly suggest this. We will be using OpenCode a little bit to show some of the capability that we can get out of it. There's also Cursor. This kind of focuses on the IDE development environment. So if you want to have a VS Code that talks to you for some reason, that is what Cursor is. I used Cursor a lot whenever the buffet was out, and we can get inference for days and days. But they've become stingy or looking to try to actually make money. So I've stopped using it since then. But I know a lot of people do use it, especially if you're in the commercial realm. It's a very popular one. I'll never be able to use this in any of my environments, so I don't know much about it, but I thought I'd mention it. One thing I have found with Cursor, when I was doing this and trying to get my demo together, is they tend to have a lot of features that they support that are broken if you look in the GitHub issues low enough. So maybe don't believe everything you read about what they say. That's just my opinion. If Cursor wants to sue me, please do not. All right. The next one up is Klein. This is another one. This is one of the best open source extensions early on that had full parity, had the ability to do tool calling, that really kind of was here before Claude Code. I have used it a lot back in the day. I think it's really fallen off a little bit, but it's one of those that's older, so you might have it in your environment if you have a more slow enterprise process. It does have a pretty good security posture. So I do want to mention this one. It's one that lives kind of inside of VS Code. And so we will talk a little bit about that, and it is in our examples for the dev containers. All right. And I'm sorry if I did not mention your favorite runtime. It's very special, and I didn't mean to insult it. All right. So the next thing that we're going to talk about is the agentic software factory building blocks. What are your Legos that we want to use that kind of exist in these open standards? Why the heck do these things exist? Do they do anything for me? And what does it kind of look like? And so this is going to be a lot of opinions that are about to come forth, but hopefully at least gives you a flavor of kind of how you might build a workflow. All right, so the first thing we're going to talk about is tools. I think this is one of the most important elements that we can kind of optimize. And luckily for us, this has gone through a lot of different cycles of how do we optimize tools. And we have finally settled on what I think is a simple answer, which is my favorite sort of answer. And we're going to talk about these 6 tools here, which is the ability to read, write, edit, use the bash terminal, do grep and glob. So, a lot of people, when we talk about tools, there's a big flurry with these MCP servers where we're adding, like here's these 10 tools, and I'm shifting these tools out for those tools. And this is all super overcomplicated. And with this sort of little simple tool set, we can do a lot of work inside of the application without kind of over-engineering our agents. And just by the ability to just do a read, write, and edit, it means that we can get really complex controls around these things, really optimize them, and with the ability to just run bash scripts. You can do pretty much anything and have heavy control around these things. So I don't have to secure 30 different MCP servers. I can just get a really secure bash script where I know this thing is controlled. And it actually helps quite a bit with the ability for the model to actually perform these things. You've got to have a good, solid command line so it knows how to do it. But with these sort of capabilities, you can get really solid performance. This is what Claude Code does. It's what the Codex API does. It's what OpenCode does. So there'll be a lot of people telling you that you got to make an MCP server for your thing. You probably don't. It's probably not a good idea unless you really, really know what you're doing. There are places where it is necessary to do these more specialized tool things, but most of the time you're just making your life hard. But there is a place for the Model Context Protocol. How many people here are familiar with MCP, Model Context Protocol? Okay, so this sort of thing is it's basically the ability to have the secondary server that unlocks a lot of capabilities and integrations into customized sort of environments. So you might hook it up to, you know, your Jira, your SharePoint, GitHub, different things like that. And they have a whole bunch of different tools with them. It's super useful, and it was the only thing that did this early on. But it has the problem that it seems to, you know, bloat the context window. There are some things that they're doing to help with this sort of thing, but it's generally not worth it unless you have something that's very, very controlled, where you want to encapsulate, you know, maybe a controlled workflow, some complex authentication, or things like that. But in general, if you don't know exactly why you need an MCP, you don't need an MCP. It should be your general rule. All right. So that is the tools. Now we're going to talk about sandboxes. This one's kind of a hard one to understand. How the heck do I do this? But it's something that's worth figuring out how to do. Because we don't want the AI on our host system with the ability to RM, RF, our home directory, which they certainly do like to do, especially models that are not Claude, although it's still really good at that too. And so we want to put this sort of thing inside of an area where if it gets kind of off into the, you know, places we don't want it to go, it can't do any harm. The most it can do is, you know, smash its own little sandcastle. And so we're going to talk a little about this. When I talk about those dev containers, this is why you do that. This is that a sandbox sort of environment. And the idea here, there's lots of different ways to do this, but one of the easiest one is to use a dev container. If you really want to go the proper next step, it would be to go and do a rootless container like Podman. But that is much more complex than I want to deal with today. So we're going to be doing a Docker container, and that'll be fine for what we're talking about. But the idea is that you have your host machine, and you have some sort of remote server that is connecting into a Docker container, and then you're just developing your environment as if you were inside of there. All that's available to it is exactly what you give it. So the worst it can do is your fault, you know. So, bully. All right. So next up, we're going to talk about agent memory. This one is an interesting one. There's lots of talk around, you know, context window. I'm glad to hear more people have awareness of the context window now than we did last year. This is obviously a very important part of working with these things effectively. It is even more interesting when you're talking about working with it in a development environment, because the proper way to maybe handle dealing with memory for these agents is to actually use your file system as that memory sort of footprint. So not have it in like some sort of an external database or things like that. Is actually just to give it there, have it there, and have it be able to do that grep and that glob over it. This is by far the most effective way to work with these things. This is how pretty much all of the agent runtimes work by default. However, it's really weird. I don't store my repo documentation for humans, you know, generally inside of my repo, unless, you know, I'm serving some sort of a doc site. And I'm not even optimizing this sort of thing for a human. I'm now storing this whole documentation thing inside of my repo that's for some robot. And so this is kind of a strange thing. So you have to kind of figure out how you're going to handle that. But it is worth doing if you want to optimize their abilities. And so with memory here, we're going to talk about 3 different types of memory. So we have the context window. That's what we've been talking about, you know, pretty much. A lot of people have been talking about this weekend. We've been talking about it all year. And that's just basically, you know, tokens in, tokens out. You got 200,000K tokens or whatever you have. And it is volatile. And as soon as you stop talking to it, it's gone. The other idea here is this sort of long-term memory. This might be where I'm storing my rules file, so your agents.md, if you know what those are, my spec files, where I'm having all my features and sort of things. If those live inside of my code base, that's its memory. It is able to go read that file and see this feature that I wanted to implement. And this effectively forms a version of long-term memory for the thing. There's also this concept of continual learning. People have been talking about this. It's parametric memory, the actual model weights. A lot of people seem to be like, we're going to train it on our output. We're going to, the model providers are training on our outputs and stuff like that. That is generally not happening unless you are really doing something specific right now. But generally, when we are talking about this long-term memory stuff, we're talking about these files here. And so these files can come in a few different ways. One of these is the agent rules. These things can be these super, super long documents, and whenever this first came out, people were getting real clever with all the stuff they were trying to put in this stuff. I would generally suggest, if you are dealing with agent rule files, is to keep it under 500 tokens or less. Keep it tiny. You want this to be something that is truly valid for every single query that goes on inside of your code base. You do not need to put your entire software development process in this thing. That is a bad idea, I'm telling you. There is somewhere to do that, and we'll talk about it later. So that's this concept of agent rules. You really want this to be kind of a transient sort of file. You really want to be this working memory. The other way that we do file-based memory could be things like specs. So we have our memory bank, which is this agents.md, claude.md, whatever your runtime does. Something that's looking like your project overview, your architecture document. Those can be your kind of file-based memory. We also have this sort of requirements and feature implementation-based memory. That's this concept of specs. So it's the same thing as if you gave it access to your Jira board or something like that. You could probably make that work, but obviously the further away you are from it being on the file system, the more likely it is that this thing is going to mess up. And so that's your trade-off, is you have to see how much can I get this into its environment versus make it available in a way that makes it useful. And so we can do this through these concepts of specs. You can do it with requirements files, if you have that sort of thing. And you can have these things be transient, pull in the ones you need. It's kind of however you want to handle it. But that is what people are talking about when they're talking about spec-based development. Generally, you will, I'll show you how this works. We will do a little bit of this in our work. All right, I will talk a little bit about retrieval augmented generation. It is retrieval. I've done a lot of stuff with RAG. It was definitely very useful early on whenever context windows were very small. It still has its places, but it is definitely sometimes something that's much more complex than you want to be dealing with. It also especially has problems when dealing with code, because one of the biggest problems with RAG is you've got to figure out how to chunk your documents, and code does not like being chunked. Because it needs its context. It needs to be able to kind of crawl up its syntax tree and kind of live in the environment that it was created in and executed in. And this sort of thing makes RAG on code especially suspect. There are still times where it probably is useful, especially if you're doing stuff that's more interesting with the multimodal embeddings. But just be careful. This is kind of like with MCP. If you don't know exactly why you're using this hammer, don't use it. Just use files. So I did say that nobody is doing stuff with this parametric updates. That is going to be a statement, I think, that has a very short lifespan. And so there is this architecture that's coming out called the Ingram architecture, where we are actually starting to be able to offload memory and store weights for these models in sort of a almost embedding that can be constantly updated and works statically and can be very efficiently computed with the extra GPU space. If you listen and crawl Twitter because you have nothing else better to do with your time, you will find a lot of the people that are working in the machine learning and AI space are talking about continual learning and say that we've cracked it. This is what it is. So if you think that's interesting, go look up Ngram and the research that's going around that, because it will be soon the case that we can actually do some of this continual learning stuff. I'm sure it'll be bumpy, but probably the interesting thing for this year would be my guess. Hot take. All right. Now we're going to talk about skills. All right, skills are wonderful. I really made fun of skills whenever they came out, and I feel bad about it now because I think these things are really, really superb. This is another one of those open standards that got started by the Anthropic team. It's really quite quite great. It solves a lot of problems with the MCPs. The idea of skills is, what if instead of giving the agent all of these different, giant plans, what if I just gave it basically a description of what's inside that plan and said, hey, why don't you go search around these things, and whenever you need it, go load all that stuff. That's all skills are. So it has some sort of a bookend, and it really solves this problem that people have been trying to solve with Agents MD, where it's putting this giant sort of process and trying to stuff it in so the thing actually does what I want it to do. And the idea is that you have your global rules with Agent MD, and then you use this concept of progressive disclosure. So as I need the information, I will then open up and find the information and then follow some sort of workflow. And this improves the ability to manage your context and not have to do compactions and kind of have the thing hallucinate much more effectively. Who here has heard the term context rot, by the way? All right. So if you have not heard the term context rot, this is a paper that came out, I don't know, September or sometime of last year. Basically went through and really measured the effect in which context degrades over time. A lot of people think that you can fill the context all the way up to the window, and it kind of gets worse eventually, but it's not that bad. It turns out it's real bad. Pretty much after 40%, every single sort of cumulative percent after that time, every single token gets worse because it's having to basically compute how much everything has to deal with everything else. And after that certain time, you hit a breakpoint where the math don't math anymore. It doesn't have enough of space to effectively measure the difference between these things. And so there's nothing you can do to fix this. You don't have fancy words that can fix it. It is a mathematical problem. So I would highly suggest, if you are kind of doing these long chats that are going over the 40% of the context window, and you're getting frustrated, know that you have a choice. Now, I'm not going to make you go do it. You have a choice to fix your problem. And that's going to be recycling your context in some way. All right, so the skill, there are 3 layers to the skill. And it starts with this metadata. This includes 100 tokens. This is what's always loaded. So an MCP loads 5,000 tokens. A skill loads 100. And that's what always in context. So you can have 1,000 skills, and you're losing 10,000 tokens of context. I wouldn't suggest it, but at the end of the day, it's only 2 MCP servers, so whatever. Then after that, you're going into your main instructions. This is kind of your level of a workflow. You really want this main instructions to solve 80% of whatever your tasks are and sort of this sort of thing, so it can go and mostly rely on this. Past that, YOLO, you can do whatever you want. I wouldn't suggest going too crazy, but I've stuck entire sites of documentation. I put the entire GitLab documentation in one of these skills. And basically, because maybe I don't have access to internet where I am. And so I could say, hey, here's GitLab pipelines. Here's some tools that go along with this thing. And here's the entire documentation. And I just have it available for the thing to go grep. Now, that's way better to me than a RAG database, because I can give this thing not just the data set, but I can give it some instructions on how to search that data set and the things that I care the most about. So skills are very cool. The nice thing is everybody supports skills because it's just Markdown and scripts. There's nothing here. So if you have an agent runtime, it probably supports skills. So I would definitely check this out. It seems like a nothing burger until you start using it and understanding what it's for. Yeah, here's generally how the thing goes. We have some skills. I'll show you kind of how that works. And the nice thing with these is that you don't have to just do Markdown with these. You can put packages in it. I have developed UV packages that live only inside of that skill, that has all of its dependencies and lives just for working with that sort of set of Markdown files. And it's a very effective pattern. All right, we're going to talk about subagents. Subagents are, I think, one of the most confused things that people are confused about when it comes to AI development. The big thing with subagents is subagents are not about personas. They're not about having these special little workers or big multi-agent systems. Subagents, what they are is a method of managing your context window. That's it. If you are thinking about them in that specific way, you have a good idea of what subagents are. This is because with subagents, they actually form basically a fork of your current thread. It doesn't have any of the prior context. All it has is what your orchestration model, your main agent has, and is feeding to the agent. And the idea with this is generally that it will go out and read a whole bunch of files. So I now have this Explore subagent. And it's able to go and read all of these files that are going to bloat up its context window. It's going to read 60, 80,000 tokens worth of files. And then it's going to write a nice little report about what was actually useful inside of that. That report's going to have 2K tokens. It's going to give that 2K token thing back to my main agent. My main agent now knows what was in those 80K tokens. And it's fine. It's not really closest to its 40% window. This is how these things are supposed to be used. And you kind of think of them almost as that you're spawning off these little things so you can bring it back to your orchestrator. And I think this is definitely the most effective way. Now, once you're there, you can do some of those specialization things like, you are a test writer, you are an Explorer agent. That stuff is some nice stuff that might help effectively narrow its context. But that is not the main purpose of these things. So we're going to talk a lot about subagents. This repo actually has quite a few subagents, and we'll show kind of how they function. These three things kind of work together pretty well. The nice thing about subagents, too, is that they can have their own skills that specialize them in being those subagents. And the nice thing is that your main agent can also load that skill, so it knows at the time that it needs to know, how do I optimize for this little guy? And you can have kind of a, here's your product owner thing, into your actual execution thing. You can do clever little cute things like that that sometimes help. So that's subagents. I love them. They are really great, but you can shoot yourself in the foot with them for sure. All right, we're going to next talk about Git work trees. Who here knows what Git work trees are? All right, I am so excited that nobody raised their hand because these things are wonderful. I wish I knew about these things before, even if I didn't know anything about agents. These things are wonderful. So what Git work trees effectively do is solves the problem that you might have had normally. I'm working on a feature, and suddenly this crazy big bug fix comes in. And I've got my code base in a nice state, but I've got to stop whatever I'm doing and go solve this bug. I don't want to commit the code that I'm currently working on. It's not really ready either. So I really need these two different sort of code bases up, and I want to do it in my same environment. And so what Git work trees do is they actually clone your repo and put it in a directory that's sitting off of your main file system. And so you have copies of your repo, but it's designed to quickly spawn up and quickly break down. Now, I know a lot of people have had to do this thing manually, where I'm going to go clone this full repo into some area over on this NFS and over on this machine, just so I can keep things together. This crazy stuff that people are doing, and this thing is just sitting inside of our systems. To be able to effectively kind of split my work and work on things in parallel. This thing is cool normally, but it's really cool for dealing with agents. Because what this little tiny workspace is effectively a mini sandbox. So it's not going to be doing its work inside of my main repo. It's going to be doing it inside of its little directory, and going to be asking very nicely, can I commit to your main branch or whatever it is? And you can do this to do a lot of things. It can help protect, if you have maybe stuff that isn't committed that you don't want to get destroyed inside of your main workspace. There's going to be lots of things like this, env files, things like that. This can help you protect those things so they're not at danger. But more importantly, it means you can do work at the same time. I can spawn 3 different agents. They can have 3 different work trees. And they can be working on different problems. They can be working on the same problem with 3 different options for how to solve it. So I can look at all 3 of them and decide, hey, which one of these do I think is actually sufficient, or do I want to blend them? So work trees are very cool, super easy to use. You just do a git work tree add, new branch name, directory, yada yada. The agents are really good at this stuff too. They've been trained on it very clearly. I think Cursor even has like native development for this sort of thing where they actually do all of their stuff in work trees. So if you've not heard of this stuff, it's super useful. All right, let's see. All right, who here has heard of hooks? Worked with hooks? All right, same folks. All right, hooks are wonderful. These basically are they're life cycle hooks. So your agent runtime, it'll expose certain sort of events that exist with it. And this allows you to basically have some callbacks that will either intercept or maybe do some after-action sort of things on these activities based on whatever's going around. If you care about having control over these things, you must understand how these hooks, sometimes they're called plugins. I think that's what OpenCode calls them. But this is critical. There's no option here. So we have two examples of this inside of our repository. We'll show an example with one where you can basically do this to apply control that's necessary for your posture and also apply control for things that's necessary for your sanity. So if it's doing things that are super annoying that you want to make it stop doing, hooks are a good way of handling that. One such version of this is my hook here that stops it from using raw Python instead of my virtual environment. It basically says, nope, use this. And I don't have to stop it and say, hey, use this every single time. It just automatically does it and continues on. And I've saved so much time just by writing this one stupid little hook. And so this is one of the nice sanity solving ones. You also have the ability to stop our rm/rf home here. So I've got a dangerous block. If it sees any rm/rf, it says, hey buddy, you can't do that. Sorry, and stops it. So you can do this for intercepting events and all sorts of stuff like that. And generally how they are done, they're usually done in these settings files. You can set this up at the enterprise level with most of these as well. So lots of times you can do sort of enterprise to machine to project sort of hierarchy on these hooks, and they apply in cascading ways. So if you are managing lots of people who suddenly have these crazy little robots inside of your system that you've got to secure, probably worth looking at this too. And generally you have some sort of matcher where it's looking for something and then some sort of a command that it uses. This can be a command that you do inline. All of my examples, I actually do these in script files. They can be version controlled, scanned, and controlled like normal. I think in general, they're good as a layer of defense with these things. And remember that these are smart robots, and eventually you can't trust that they're not going to know about the hooks, but you should do kind of a defense in depth with these things, pretty much always. I think really there's two different types of hooks whenever I'm looking at these, and there's a gate sort of area where a request comes in. There's some sort of event, and I want to either block or allow it based off some criteria. The other one that we'll talk about, where I've actually done something with monitoring with OpenCode, so we do some open telemetry and tracing, where you can see an event come in and have some sort of observer process, and that can go to your log collector or something like that, and do a log or metric or let it go to the next step, so it's none the wiser that somebody's spying on it. All right, those are hooks. Love hooks. All right, we're almost through my yapping, so thank you guys for putting up with it. All right, next we're going to talk about monitoring. So this is figuring out who did it in the server room with the chainsaw. All right. And so one of the things I love the most about this, we're going to go through a tool called Arise Phoenix. This is one example of a self-hosted monitoring system that you can utilize that gives you really good information about these agents and the turn-by-turn sort of things that they're doing. There's lots of other ones available. You can cook your own. You might have access to one already. People can use Prometheus and all those sorts of old stuff too. But I like pretty pictures, and this helps me out. So I'm going to use this one. We'll pull that up so we can actually look at it and not just look at a picture. The big idea with agent monitoring is we're not just looking at the system health. Is it working? Our latency, error rates, throughputs, events. We really want to look at what are the prompts that are going in? What are the tokens that it's costing? So if I'm calculating cost. How are the tools being called? I can do things like my hooks, see if they're working like I expect them to be working. Are they adding latency or doing weird stuff like that? You can do things there. How's my retrieval system working? You really want to track those sorts of things, especially once you start getting into agents calling agents, calling agents, calling agents. This becomes really critical if you're trying to secure an enterprise application. So yeah. Generally how these things work is that they set some sort of a time period that starts with a session at the very top, and it goes into a trace, and it goes into a span. you don't really need to know what that is. It's just a hierarchy of like little tiny events where spans are your smallest event. There are open specifications for this for generative AI. So if you are doing things where you're trying to do metrics, please look up OTel, which is Open Telemetry, and there is a Gen AI semantic conventions. And these are generally able to be used to log and be able to run in any platform. So if you're doing a lot of cross-app, cross-company collaboration and want to be able to effectively share your logs without a bunch of extra work that you've got to do, I would highly suggest going and looking at this. This is the Cloud Computing Foundation, Linux Foundation, Kubernetes, all those sorts of folks who are managing this stuff. It has got a lot of people behind it. It's sticking, so I would check it out. And so yeah, how Arise works, basically, your agent goes into an OTel export into a collector that ingests it, puts it in a database, and shows you pretty pictures. So that's how it works. All right, we're at the very end here. We're going to talk about dev tools, things like that. And so I am not a Rust head. I've never programmed a line of Rust in my life, probably never will. But you know what I love? I love tools written with Rust, because tools written with Rust are fast. And it really, really matters how fast they are, because I want this thing to run validation as often as possible, and I don't want it to take a long time. And Rust is not just a little faster than your traditional dev stack. So there's pretty much, you see everybody is rewriting their dev tools in Rust. This is why. You're talking about ESLint going into Biome, which is the tool that we'll be using today. It is a 40 times speed up in how long it takes for it to run that validation on whatever your rules are. For Flake 8 to Rough, it's 100. MyPy to TY, it's 60, and pip to UV, it's 100 times. That's all that time that you're not having to wait when you're spinning up these new environments, these new work trees. I'm spinning up 3 different things of these agents and having them run this stuff. We've cared about this stuff for running just in normal CI, but with agents, it becomes so much more important because I want this to be snappy, and I want it to be not so slow that the agents cleverly figure out a reason that they didn't need to run it anyways, because they will. If things take a long time, they'll just decide to not run it. Ain't that fun? It's like real programmers. All right. So next, we're going to talk about context sanitation. This is dead code analysis. This is also very important. So it's basically finding things that are inside of your code base that nothing imports, nothing uses. You've got things exported in a public API that nobody calls. Sometimes this is something that you want. And sometimes you need to do, there's a reason you're writing a library that has no consumers. So it has controls to allow for that sort of thing. But I would highly advise looking at some sort of a dead code analysis, especially if you're doing a lot of code generation with the agents. Now, if they're mostly just kind of analyzing code, you might not need this sort of thing. But they are really, really good at writing the same capability 5 times and then leaving 4 of them dead. So if you're doing code generation, you should consider having this somewhere, even if you're not running it all the time, just to figure out what crap they've done. We're going to talk about 2 MCPs today. I said there's sometimes a really good reason to use MCPs. There are 3, I would say. I'm not going to talk about one of them. But the 2 I'm going to talk about are Chrome DevTools and Playwright. These are both really, really good for specific reasons. Basically, the agents aren't good at dealing with the CLI with these things, and they don't really know what to do. And the MCPs are so well designed that they just work for handling this. Chrome DevTools is really nice if you're doing browser stuff because it allows it to get access to your actual environment, and pull network data, pull things from the console, and get performance data if that's stuff that matters to you. We're not looking at performance on our little Rocket application. We're not doing Chrome DevTools today, but we'll do some fun stuff with Playwright. Who here knows what Playwright is? Browser automation, that sort of thing. All right, so we're going to be talking about that. We're going to use it in a weird way, actually, to actually use it to help the AI design a feature instead of test it. So that's going to be kind of fun. All right, last little bit, talking about testing with AI. I think this is one of the biggest dangers because it was one of the things that everybody claims, like, AI is really, really good at writing tests. It's going to write the test that I don't want it. Well, there's a story underneath that sort of claim. So AI is really good at getting high code coverage. And the way that it does that is probably not in the way that you actually want if you care about catching bugs in your application. Because the AI, usually writes that code by looking at the implementation of your application and writing whatever it needs to make that pass. And so, yeah, the code's going to run, but it might not be testing something that's actually useful. And now your canary in the coal mine that code is untested, it ain't singing. So you've really kind of all you've done is broken your fire alarm. And so they will look at the source code, and what we need to do is find a way to either not have it write those tests or force it to write those tests only from the requirements without any knowledge of the actual implementation. We'll talk a little bit about that. There's still some problems with this. I have lots of suites to try and make it do this. They're getting better at it, but I maybe wait around for Claude 5 for really offloading that sort of thing. We'll talk about it. So yeah, the idea here, there's lots of different problems with this. Number one, it's maybe just kind of a useless test, but also be really bad too. If you have a bug in your code and it's looking at the implementation to determine how to code it, it's going to enshrine that bug as how the application is supposed to work. And this happens constantly. And so you're not only killing your canary, you're training it on the wrong thing. So it'll do stuff like this where I've got my return sum, and it'll say, take that sort of thing, and it won't call the function, but it will re-implement it inside of your code test, and then test that value. And so it just happens to do. And what will happen as soon as you change that, this test will break. It's because you didn't test the behavior, you tested the implementation. No good. The other main issue that these things have is tautology. It's basically the saying of the same thing twice in different words, generally considered to be a fault of style. They do tautological tests. So examples of this is, he's an unmarried bachelor. They arrived one after the other in succession. The frozen ice is cold. She gave me a free gift. Yippee. And the way that they do this is that they will say that, I've got this return processor, status is success, and I'm going to I set the mock value status to success. I'm going to test this if the status is success. I'm going to set the value on this object, and I'm going to test if it is the value that is on that object. I'm going to mock the function I am testing and change how it works, and then test if that's what works. It sounds stupid, but it's what they do all the time. If you actually go in and read that code that these things are putting out, it will be littered with this stuff. So if you have recently heard your code coverage numbers are going up and you're responsible for that number, be warned. You might have a bomb on your hands. You don't know. The other big thing that these things do is these existence checks. So anything that's really easy to kind of prove and go through the motions that it is and get to that green check mark. Because they're RL trained. They just want that green check mark and they get the points. Nobody's testing these things for good tests quite yet. All right, last slide. Yippee. All right, so last thing we're going to talk about, who here is, I'm not expecting many people have, who here has heard of mutation testing? All right, this is fun. So how about fuzz testing, that sort of thing? So mutation testing is fuzz testing for your code. We're going to have examples of this. I had never heard of this thing before, but it is especially effective at catching crap AI tests. And basically how it works is it takes your source code, and then it just mutates little values inside of your code. So it might change a divide to a multiply. It might add a whole bunch of strings on it. It messes up at the fundamental level where it's breaking your code. If your tests still pass after it's broken their code, it ain't testing anything. So you're looking for this your test to fail. That's good. You want your test to fail if you break your code. If your tests pass after doing that, no good. We'll have some examples of that later. All right. So fire hose is done. Thank you guys for handling all of that. I tried to get through. Hopefully that was at least somewhat useful as far as something to maybe look up at a later point in time, if any of that sounded interesting to you. I'm going to go ahead and get started and kick this thing off. Like you said, we have this little application here. I've got some preset things going to go up, and we're just going to walk through and watch it work. And so I've got this feature demo here. We're just going to go ahead and let it do this sort of thing, and we'll look at it first. Actually, I'm going to go ahead and kick it off, and we'll go look at it while it's thinking. At this point, we're kind of go through a lot of periods where we're just waiting for it to do its job. So if you have questions as we kind of get going, this would be a good time to hit through them. But I'll go through a few small things first before we get there. And so just an idea of what this thing is doing. It's this little slash command that I have, which is basically a preset command. And it is going to go ahead and do those skills. So I have this test driving with AI skill. It's going to load that up, and it's going to kind of have it go into this weird TDD style loop. It's going to bring up the application, explore around the code base. So I said I'm going to send this thing out. It's going to read a whole bunch of context and provide reports. So we're going to see it do that. It is going to use the spec writer subagent, which I have fed the way to kind of do the easy approach to requirement specifications, which is kind of a nice little way of specifying requirements that these things seem to be able to handle. And it's going to write me a spec file with requirements, and then we are going to have it ask us questions if we like the feature specification, get some feedback from us. And then we're going to use our very, very special agent called the slop test reviewer. And it's going to help our thing plan about how not to make slop tests. And this will marginally make its plan a little bit better, but it'll still have some trouble probably. Then it's going to go and do some review, and yeah, we'll see. So that's kind of the general idea of what this thing is going to be doing. Okay, it wants to kill some processes. That's fine. All right, and so it's going to go ahead and start adding our background here. And so let's see. So you can see here, this is where it's loading in the skill. So up to this point, it only had this little tiny segment of this skill inside of its context. And this test driving with AI, it's got a whole bunch of data here, all these sort of files that it can go look at. But this is the actual file. This is your description. This is what's always loaded. And then it's got all this gorp about this process that I want it to go through. And then it loads that in, and that's what goes into the context at that point. But until it needs that, it doesn't have to deal with it. All right. Seems to be, oh, I left something open, didn't I? Okay. Okay, well, it has closed it. Very good. All right, so we're going to let it work. I guess while it's going, do we have any questions, any comments, sort of things, as we let it kind of work in the background?
Hey, Josh.
Uh-huh.
For the hooks, is there a common library out there that's open source that are like things that you definitely don't want it to do?
I think there probably are examples of that. I will see if I can find. I have an idea of where to look, but I will add it to the repo if anybody wants to look at it. There is this references sort of section on the documentation site, so I'll try and throw some stuff there. I would like to look at what they have before I recommend it. So.
Do you use an AI to establish all the skills needed and then write them?
It depends. So I will use the AI a lot for gathering the references. And usually that involves scraping sites, because I'm just looking to get that stuff into my system. A lot of the times I will write the skills myself. Anytime that you're kind of doing these core prompts, it is good to have those core prompt engineering skills and not just offload it. Now you can. I would say, you can start, with, maybe feeding it to Gemini and having something else. But I would say at some point you should have a good understanding of exactly what you're asking these things to do. Would be my suggestion. All right, so we can see now it is going ahead and it's looking for a work trees directory. So I've told it to use those work trees, so it's kind of poking around there. You see it's doing these explore agents. And so look here. You can see all of this context here, 49K, 68K. That's stuff that my thing doesn't have to look at. And there's going to be another one here. It's going to end up being 150,000 tokens that it has effectively searched without bruising its context window. It's going to end up being probably, I'd say, 4,000 to 6,000 tokens. So very effective. You can see here, too, that it not only did that, but if you have a good agent system, which Claude Code and Open Code both do. I would say, I'm serious, Open Code is quite on parity with Claude Code. It will split this stuff in an effective way. So it's saying, one of you go to client, one of you go to test, and one of you tell me about the shared types and data flows between all of these things, and tell me exactly what that is. That means that report's going to be cohesive from each of them. All right, so now it's going to go into the spec writer subagent. Spec writer, I have given it special instructions to use, to not just write me the spec, not just do the easy requirements. It's supposed to not look at the implementation. So we talked about that for the tester. I also want my requirements to do that too. I don't want implementation of my requirements. I want it to go and use the app and poke the buttons and tell me what it wants to do based off of that. I didn't talk about this, but the very, very mission critical feature that I've asked it to write is to let me change the color of my rocket and the fins. And so it's going to be going and figuring out how to add a color selection so it can best show my personality.
I have a question.
All right, what's up?
Do your subagents that you're making your calls on here have a context window that they're storing?
Yes.
Okay.
Yes,
so-
they have their own, they're like a whole other agent.
Okay.
Yeah, and then they exist for the length of that task, and they're gone.
So if you find an issue on this that you think is associated with one of those subagents, you could make a call for that subagent to change it?
Generally, I would not make that call. So if you're trying to interrupt subagents, I think OpenCode has the ability to do that a little bit more. Claude does not expose that. But generally, they're just kind of like a one and done sort of thing that goes out. And so you can reject the outputs of the sort of thing. You can stop it. That's generally how I redirect them. All right. And so we can see here, it's taken screenshots. And so the spec writer did its own thing. And now the fun thing is that now it's the main agent has gotten this report back. And it's decided, what the heck is this? And it's going to go look at the web application now, too, to see if it understands it. It's apparently what it's doing here, which is great. I think that's wonderful. We want this thing to do this. It's not going to hallucinate this sort of stuff because it's actually poking at our application, being able to see the things that are coming out. And so if we look over here, let's see, find my Playwright MCP. I love the Playwright MCP. It's one of the best ones. These things suck at the Playwright CLI. And just giving it these 6 tools, it's enough to make it make sense. In general, the multimodal intelligence on these things lacks because of just how transformers work and how, like I said, I'm not going to get into the VIT stuff. That was my promise. But there's lots of interesting reasons why Vision kind of sucks. And this is a way to help unhobble them. And it's taking pictures, and then it's going to use its Vision transformer to just kind of see how it works. Oh, okay, I can do this sort of thing. And it's looking at that and making its decisions from there. So that's super cool. All right, so it's now done all that. It's getting into its plan mode. And it's doing the last thing which I've asked, which is not just to do its plan, but it's getting some external context from 2 reviewers I have, one of which is my slop test reviewer. I'm saying you get some time with the judge before you make your plan. Here's your one chance to kind of get some pre-work in. And then also another one I have called the code simplifier that looks for overly clever gold-plated solutions and maybe suggests an alternative. So it's going to do that for a while. Do we have any other questions? Okay, we can watch.
Test reviewer is reviewing the plan before it goes.
Yes. Yeah. I found that this works. So I didn't originally have that, but sometimes I'll just try stuff out. But you just kind of have to get a vibe of what might work, what's worth experimenting with, and kind of as things start working, be willing to experiment with these things. This ended up working. The whole idea of the slop test reviewer actually came from using the code simplifier to do the slop tests. I just specialized that agent. And so just kind of be willing to try stuff out to see what works.
So the intent for Playwright wasn't for testing, it's purely just to capture images to...
For this one right here, yeah. Now I also am just testing with Playwright.
Right.
So I have like pure end-to-end tests inside of the code review. I'll go ahead and do that while we're waiting here. Okay. Oh, it's got everything cached, so it's going to go straight through. But you can see sort of all of our tests. That's the nice thing about Turbo. If I've not changed anything, it'll just cache the test. But we've got a whole bunch of stuff. We've got 33 or so end-to-end tests, I believe. And so we're just using that normally here, which is very useful. Okay, here's one of my favorite things. The Ask Questions tool. This is one of my really solid things that some of these things are starting to implement, which is the ability to, if it has a question, it can present you with some sort of queries that help refine stuff down. It's asking us here, it had some questions about, how do we want to use these preset color buttons? 8 colors is fine. Do we want to add the ability to have a third selector? I don't, because it's 405, and we're going to submit those answers. And so now it's going to finally get to its updated plan. And while, yeah, this might seem like it takes a lot of time, it sure is a heck of a lot faster than reviewing a feature that I don't like, that isn't what I wanted. And so it is worth the upfront investment to get this stuff done. The nice thing is, too, is that now I have this plan file. And so if this thing just totally blows it and gives me crap, if I'm still happy with the plan file, I just hold that plan file and do another run. Delete the work tree and try again. And I've saved myself 30 minutes of specification. All right, so now it's going to present me this plan here. Most of the things will support this now. It's going to give me this big, long plan because I've given it so much information about how I want this to look. So it's going to, from the very top where I asked it to implement this feature, it's going to give me a product specification. It's going to give me user stories that match exactly what I want. It's not hallucinating these things. This is only going off of what I asked it for. Looking at what the application currently does, what we are proposing that it does, what the acceptance criteria are on this with a given when then sort of syntax. We're going to go right through this just because of time. And then design decisions that the user specifically made. So these aren't really supposed to be things that are variables for it to play with. And then a simple implementation plan. And this probably, you see here that it got simplified. This was probably a comment from the code reviewer, my code simplifier, where it had did this giant, elaborate plan about how it's going to do all this. And that guy basically said, hey, buddy, why don't we chill out with that? You're not doing the work, so stick to your job. That's what I'm seeing here, specifically how it says this right here. OK, so we're going to let it do this. So here's another big thing here, is that now, because I've got this big, long plan, I'm going to reset my context window. I am back to 0. And so it has that plan now, and I am way before my 40%. That big skill that I loaded, it's gone. All that context is gone, but it has clues to where to go. This is kind of the way that you can deal with this context window churning. All right, so it's going to go do some stuff, and let's all wish them the best and talk about some other stuff. All right. So, any other questions, comments, sort of thing? How many people have seen this sort of workflow before, are experimenting with this sort of thing in your environments? I'd say this looks a little bit like what people are doing on the edge. Yeah.
Which models are you using with OpenCode, and how are they comparing with Opus and
So OpenCode, my favorite one, if I am on the outside, is definitely using Codex. I actually do use Codex 5.2 quite a bit. My favorite place to use it is OpenCode and not in Codex. It gets obviously the direct integration. I do also use DevStrol when I'm kind of in an environment that I need to do a locally hosted model. The new DevStrol 2 small can do quite a bit of work. Now you do need to understand, as you're scaling these models, understand exactly what they're capable of. So I will do a lot more of reviewing code with that DevStrol small sort of model, but it's pretty good. The least powerful model I would probably do this sort of stuff with would be GPT OSS 120B. It can kind of get this sort of thing, but its attention has problems. Anything up above that's fine. I've played around with the GLM 4.6V models. Useless for my daily work, but it's fun for doing some of that tabletop stuff. So I don't care about. All right. Sure, whatever. All right, other questions, things like that?
I'm reading about something called Gastown. Are you familiar with this?
I have never heard of Gastown. What is Gastown?
It's an orchestration layer.
Okay. Mm-hmm. Yeah, I generally, I have not offloaded my orchestration. Generally, the most I will do is 3 agents. It's very weird for me to be doing it on the small screen. You know, I definitely like my big wide screen with agent, agent, agent. It really lends itself to this sort of work. I just have to convince my PM that I need it. I would be concerned about offloading my orchestration right now. It's just such a finicky thing, and to try and delegate that to somebody else, or like some non-human or some third party, that would concern me at this current point in time, I think. Yeah, that's just me. Maybe I'm paranoid. All right, it's writing test. Run a test. All right. What are we doing? I think something is hung up.
Is the proxy ran in the repository?
Yes, pretty much everything's in the repository. Yeah. There we go. So it looks like something got hung up, and so I'm redirecting it now. You do have to still watch these things. The tests are hanging because they're waiting for elements that don't exist yet. Well, yes, that would be a problem. Okay. So we've kind of prodded it along. You do have to still watch these. This is part of the reason I said, the exact reason why I said I don't really trust handing off this orchestration. Each of the agents will start failing in strange, random ways that you cannot predict that might be different from one day to the next. And so you just kind of keep an eye on them. There we go. Okay, so it's unstuck. One thing, too, to remember is that these things have no actual understanding of time and what it means to wait. And so it will do lots of very strange things with timeouts, which is another way that you can lose a lot of time if you're not kind of monitoring it. It'll do like, I need to do an LS on this thing, and I'm going to time out for 10 minutes. Like, no, don't do that. If it fails, I want to know now. So you just got to keep an eye on it. Okay, it's doing stuff. Other questions, comments, things that we want to see while we're waiting around? There's a lot of this. This is really why I run 3 or 4, so I can do something while I'm waiting. I will upload the slide deck, yeah.
Where are your sub-agents stored in here?
The sub-agents, so one of the things that I've done is, let me get my file browser, okay. So we have a .agents folder here. This is kind of a burgeoning standard, just like agents.md. I have everything for all the agents stored in here, and I am symlinking them in my dev container setup process. And so the agents are here under here, and a lot of these sort of special ones that I wrote are under sub-agents. There is this code simplifier here as well that actually, this is an Anthropic definition that I have then modified for the other ones. So.
Syntax matter in these at all, or is it just all?
As much as it does for any other prompt, I would say. One big thing, if you have not started doing this, is the concept of marrying Markdown with YAML. It's very useful because you can kind of put this YAML front matter here and get some of that control over these things. You can do search, you can do structured validation on at least your metadata. This is used a lot with these agent files. So if you need some sort of structured stuff with your Markdown files, because I don't know how in the world we got to where we are running Markdown as code, essentially, but we're here, and so some of us have to deal with it without going crazy. So this helps a little bit. All right, let's see what I got till 10 more minutes. It's about. All right, I'm seeing things. I think we're going to make it. I think it's going to get what it needs to get done. All right, so while it's waiting, I'm going to show a little bit of the mutation testing. This is kind of cool, just to kind of give you an idea of what we're looking at here. So I've got this here, just an example of this, and we've got a whole bunch of things that have survived here. And I'm just going to show you one example to give you an idea of what this is. So we're going to look at one of these that did survive, and I want to go back. Here we go. Yeah. All right, and so where did that one go? I've got it anywhere. Here we go. All right. So what it's done here is it's added a little striker was here to this dependency array. If you know anything about React, that's not valid. That is super not like a thing that you can do. And so it's just basically broken this thing entirely. So we can see here, it's added some information. This is my favorite, where it has changed the animation interval for this thing from 1,000 divided by my FPS to 1,000 times my FPS, which that's probably not good. And so it's just messing stuff up. And if your tests are still passing after this, there's your problem. So this is really cool. It's kind of slow, but you can do stuff where you only run it on changed sort of things. So this is something that's good to run every once in a while or on new code that's being written. And you can find some funny stuff real bad. You don't need to target 100%. I think generally 60 to 70 is a good area because sometimes there's a reason why something wouldn't break that's valid. But if you have 20% as your kind of kill rate, it's probably a problem. And that's a realistic number that these things will do. All right. All right, buddy, come on. Okay, so it's on to testing. I'm going to peek a little bit. Let's see if it's been able to do stuff. Okay, that's a good sign. All right. There we go. Ta-da! It did the thing. I'll be waiting for my Emmy any day. All right. So that's kind of what all that looks like. We've got about a few more minutes now. It might just make it. So generally what I'm going to probably do after this, I almost guarantee you that it's done some slop tests here. Like I said, these things just do not get the concept that we're trying to tell it of like, hey, you need to not look at the implementation. Now we can basically roll it back and catch it, but at the end of the day, it's still generating it that way because of a fundamental lack of a world model, essentially, of how to do proper software development. So it can even see the problem, and then it will repeat the problem again if you just kind of let it go. So I think that there's still some probably capabilities that are needed with larger models, but you can kind of hobble and push it in the right direction with lots of human redirect right now. So. All right, let's see if we can go peek into some of this file. If you do repeat this enough times, it does end up getting there. Yeah, so seeing stuff like this, I'm not super excited about that. It's hard-coded hex codes inside of my test. This is an example of some of these implementation problems that we have. I would generally like to see that to be something else here. So yeah, it's got kind of some sloppy tests. Let's see if we can, we're going to start a new thread here. I'm just going to get a little thing here. Let's see. Let's see what it says. All right, so we're going to see if it can pull out some examples for us from that. I think it is pretty good at that. All right, other questions, comments, musings about the world that we have found ourselves in?
So I think you alluded to it earlier, where you can bring in a larger context for like if you're in a high-side environment.
Mm-hmm, yeah.
Right? And you're working with software that is, or software libraries that are more up to date than what your model's been trained on.
Yes. Yes.
So like, how would you go about bringing that in?
You're working with software, then you're. Oh, okay. Yeah, sure. I can show you.
Or something like that.
Yeah. Let me see. Let me go through my skills here. Okay, so here's one. So it's using the Arise SDK. That's one of these here. And I basically have got my skill. That's that main file that's there all the time. I've got my scripts. And so my scripts here are just basically useful. I've got some templates that I kind of specially guided it through of like, here's how you use this. And it can either use these directly, so it can call these from the command line with this bash tool. That's super useful already, because I can just kind of skip it having to learn this sort of thing. And it only just exists as these little one-off scripts. It can also use these scripts as a reference for what this working code looks like. Or it can go in and pull, maybe my scraped data here, which you can see here. This is just straight up scraped from their documentation, straight from their markdown stuff. And I haven't done any post-processing on it. I fully trust even like a GPT OSS to go and get me scraped documentation with a firecrawl MCP. And this is super easy to say, hey, this is secure. This is a text file. Please load this into my environment. But at the same time, you're getting the benefit of having your reference. So I think this is super cool for sure. All right, I got 4 more minutes. Let's see. Have you hurried along? Okay, it's still thinking. That's going to happen sometimes. We want it to take its time. All right, other questions? What's up?
So you spawned the other agent, swap agent
Mm-hmm.
section. You said intern, but it's not included the arguments and the rest of the markdown, so it really ignored you when you said intern, right?
No, I mean, that's the nice thing about these things. They're not programs. And so you can kind of just, give it some weird stuff sometimes and it'll figure it out. Okay. Yeah. So that's kind of a thing to help it. If you're chaining stuff, it helps it kind of also let the humans know how it's intended to be used, which I guess we can still do some stuff, I guess. So it's helpful. All right, 3 more minutes. Any other questions?
So more ways to optimize subagents.
Okay.
Past commencing down the context.
Okay.
So you mentioned after you get to that point, adding skills,
Mhm.
customizing them, any other things.
Yeah, absolutely. So other ways to optimize subagents, you generally can specify a specific model. So if you have a subagent that you want to run with a smarter model or a cheaper model, that's a way you can optimize them. You can also generally assign hooks. So you can specify a specific hook just for a subagent. Now, not all runtimes support that. That is a more advanced feature, but I think both Claude and OpenCode do support that. And so those would definitely be my 2 biggest ones. Would be going after those 2. Yeah. All right, another question. Okay, sweet, student checker. All right. Well, thank you guys. We'll still stick around a little bit here. Let's see what it does. I appreciate you joining for the talk. Hope this was at least interesting and has some useful patterns. If you want to talk about this sort of stuff, feel free to come up and chat offline. I'll be around. So, yeah, thank you.